Hello and welcome everyone. My name is Galder. I work for the Infinispan project, and today I want to show you a little application we built on working with the streaming data with Infinispan and vert.x and RxJava that you can deploy on OpenShift. And today I'm going to walk you through the application. We're going to be running locally from scratch, so you'll be able to see it how to run it in your own environment. So we're going to start by looking at the github.com/infinispan-demos organization, where we have little sample applications on to be used with to show you how to use Infinispan. So what we're going to do in our application, we're going to be working with two streams of data for which we've already downloaded some captures. We've captured some data that we've stored in a repository called Swiss Transport Binaries. So what we're going to start is by taking this repository. We're going to copy the link. We're going to go to our command line. We've created for today a little folder called screencast. We'll look at it, it's empty. So what we're going to do is we're going to clone this repository, and that's going to contain some files that we're going to be using to in our application. The idea is that we're going to take this, the contents of these files, and we're going to stream them into our application, which then is going to store things eventually into Infinispan, and then from there we're going to be reading them. Now, overall, while the Git clone happens, we're going to go to a little diagram that I have created where I explain at a higher level architecture of how things are going to work. So we have the files which substitute an HTTP endpoint. So we've captured the data for 3-4 hours and we put them in files so that we can consume them and we can get reliable outputs. Then what we're going to do is we're going to use vert.x, which is a toolkit for building reactive applications, along with the RxJava APIs to read from these files and put them into Infinispan. Infinispan here is going to be our kind of in-memory data store where we're going to temporarily keep the data, and then we're going to extract meaningful data out of it in our mini analysis tier. And then from there, we're going to push the data that we're interested in, and we're going to use vert.x again to push that data over to two applications. One is a JavaFX application. The other one is going to be a web application. And what we are going to do to start here is we're just taking the binaries for now. And in the next step, what we're going to do, we're going to take the actual code that we're going to be using today. So if we go to our command line, we see that the transport binaries have been downloaded, so that's fine. We go back to our web browser. The other repository we need is the streaming data Kubernetes. This is where the logic is going to reside, and also we have some scripts in there. So we go back to our command line, and we do git clone, and we clone that repository. While that is happening, because it takes a bit of time, because those binaries that you see that are now part of a different repository. Before it used to be part of the streaming data Kubernetes. The reason we've separated the binaries is because in the previous version we used to deploy the application together with the binaries, but obviously this bloats our application itself, so we want to keep them separate. And then later on we'll see how we can plug those binaries in a local environment into our application. There are multiple ways to do it. We've just chosen a particular one that relies on host path information, but you could have used other setups where you can where we rsync information into a particular directory, or for example we download it from some cloud storage. Then on top of that, I also wanted to show you a little component architecture. So what we can use OpenShift as your running environment. In there, what we're gonna end up doing is we're gonna create a 3-node cluster of Infinispan, which is going to be represented by these 3 pods here. Those are going to be within a data grid application. Then the application is going to be talking to the data grid via the data grid hotbird service. in the Kubernetes world means is the entry point in which the applications connect within a Kubernetes environment between each other. So what the application is going to do is going to read those files using two verticals. So we're going to use the station boards vertical and a train positions vertical, and they're both going to read independent data, and they're going to push it into the data grid. Then out of the data grid, where we're going to extract this information about delayed trains, we want to find out of all the station boards that we get from around the country in Switzerland, which of those entries are delayed, so to find out which trains are delayed. And then we are going to combine that information with the information about the positions of those trains. So on one side, we're going to be able to create a dashboard with all the trains that are delayed, which is going to be exposed by this event bus address, which I'll explain a bit more later. And then we're also going to combine that with the train positions to create you a little Google Maps where we can see where the trains are located. So if we go back to our terminal, we see the repository has been loaded. So I'm just going to quickly load up my IDE. And from the IDE, I'm going to be asking it to load the repository of code. So I do here, click open, then I go on to the screencast folder, I select the streaming data Kubernetes folder, and I click open. So while that is happening, what I'm going to do is I'm going to start by starting OpenShift. To do that, I have locally a OpenShift client libraries for OpenShift 3.7.2, which are, I have an alias for it called OC37 that brings all the libraries that I need to use OpenShift client. Mostly is OpenShift, but also verify that I have kubectl in case I want to use that as well. So what I call is I do OC37, that brings OpenShift client into my path. And what I need to do now is if I go to the streaming data Kubernetes folder, I have a script that basically will start my OpenShift cluster for me. If I look at the this file, it's called setup local OpenShift. What this does is it stops any OpenShift cluster. If there's one, then I load it up. And then what I do is I take and give special access for my project to access the host paths. This is because the binaries are going to be in a host path, so I need to give it my project permissions to be able to access that host path. That's what I'm doing in this line here. Then I log in as developer, which is going to be our credentials. And then what I say is just I load a couple of templates that we have included within the repository. These are templates that enable us to create Infinispan instances. So if I go to the IntelliJ path, one thing we're going to do, since the application has already been deployed, is if we go to our application, later on we'll be using this host path to take those binaries and read them. So what I'm going to do is I'm going to go to first deploy script. And here we just explain how we're going to deploy our application. We're going to be compiling it, and then we're going to be using OC start build to do a binary build of our application. The way it does, it takes the folder, pushes it onto OpenShift, and then it runs the steps in this Docker file that you see at the same root, at the same level. Now, the one modification we need to do is, as I said, the binaries are going to be read from a local host path. So what I need to modify the path to point to this particular path. So I can do users/g is my home directory, and do a screencast/Swiss transport manuals. This then is going to be mounted into the /data path. Okay, with this in place, I'm going to go back to my terminal, and I'm going to call my setup local OpenShift. This one stops any existing OpenShift clusters, and then it does OC cluster up, which starts an OpenShift cluster for me. While that is running, we're going to start looking a little bit at our application. So our application is going to have a main entry point, which is also called main. And in main, what we do is, this is the starting point. We create a little web server with a few endpoints for us to kind of play around with. And to start, the most important one is going to be the one about inject. Inject, essentially what it's going to do is going to say, okay, the two, I want to start up those verticals that are going to inject our data. These two verticals are called on one side station boards vertical and the other one train positions vertical. Now, what you see here is you see RxJava APIs being in use. So what we start by doing is say, okay, if I call inject multiple times, please undeploy any previously running verticals. And then deploy this vertical. If that succeeds, assign the vertical ID locally so that I cannot deploy it if it goes again or on the stop. Then deploy this other vertical. So these calls that you see here is how you these calls actually come from RxJava. This is the calls that enable you to coordinate asynchronous operations. This is a key thing about vert.x. It enables you to implement asynchronous non-blocking applications where very few threads are used, and it makes the most of the resources available. And RxJava APIs are very good for coordinating those asynchronous operations. If you are a Node.js developer, then you will have seen this being done with callback handlers. But callback handlers are very difficult to read. They quickly span multiple levels. And I find Rx APIs are easier to understand once you are familiar with them. Now, what is this station? So initially we're going to be focusing on the station boards vertical, which is the one that is going to take information about station boards. So that means that if we look at the station board in Zurich, for example, it's going to tell us in platform X9, or there's a train coming that is going in this direction. And all this information is the one that you're going to be reading and injecting. For now, we see here some information about what it does on the start. We're going to ignore most of it, and we're just going to say, okay, when a station board's vertical starts, it does something called inject. What does the inject do? It takes the file. This is the binary file. The /data is the mount path that we defined earlier, and here we see a zip file that is we're going to be reading. What we can do is we call something called RxReadFile. This is a local method that reads using RxJava and vert.x APIs. What it does, it creates a flowable. A flowable is an RxJava2 construction that allows us to emit more than one entries in it's used for situations where you want to call an operation that returns more than one entry. So flowable basically enables us to consume one entry at the time. In this particular case, what we're going to be doing is reading from the file, and each line is going to be one invocation into our flowable. Then from the flowable, we're going to generate the flowable from reading our file. We're going to unzip it. We're going to start reading one line at a time, and we're going to emit it into our flowable. Now, what we are going to do in order to give a little bit of smoother experience, so not try to read as fast as possible, then what we're going to do is slightly throttle for now. We're going to throttle it to say every 1 second, take one line and put it into the flowable. Wait a second, put it into a flowable. This is what this flowable interval just does. It basically says every 1 second, just give us the next line. So if we go back to our station board vertical, well, we take each line, and when we map it, we convert it into a key value pair. And the key value pair later on we're going to be using to store it into Infinispan. But for now, what we're going to say is we're just going to log it into the standard output that we are reading. So here we're just making sure are we able to read the file correctly. So if we go back to the command line, we see that our script has run. So we've started OpenShift. We've give the correct access to the host, and we've loaded our templates. So now all we have to do, we take the the URL of our OpenShift. We go to the Chrome browser, and we just load it up, and we call developer. That's our credentials. So here, if we go, we can see that OpenShift is loaded, my project is running, so fine. So what we want to do next is we want to deploy our application as is. To do that, what we are going to do, we go to our to the terminal. We go to the app folder. From there, what we do is we can call Maven Compile. That's going to compile. Actually, first, because we've not yet deployed our application, we're going to call first deploy. First deploy is that script that you saw earlier, where I defined my build. I define what initially I'm going to do, which is a star compile and a star build, and also I create a new application, which happens once, and I expose it externally, and I add the path to our transport pipeline. So I'm going to call first deploy. Okay, so that's gonna first it starts a build, then it does a compiles our applications. It takes the dependencies as well, and then from there, what it does, it goes to start build to run our application. So now we've seen that it's pushed it, it's created a new application, and it's exposed it, and finally it's attached the path. So now we have our application has been deployed. So if we go to our OpenShift, we can see it's already up there. It's got one pod. We can go to this particular pod. We can click on one, and we can click on the logs, and we see what it currently prints. So there's nothing being printed so far. So what we are going to do now is call the inject on the application. If things are working fine, what we should be seeing is we should be seeing entries being read and appearing in the log. So what we can do, how do we call inject? If we go to OpenShift, we can go once again to the overview, and this application supposes a root. This is an address which is externally accessible. We can just right click it, we copy the link address, we go to the command line, we can do curl on the address and call inject. Now this gives us a little error. This means that one of the verticals, in fact the second one, the train positions one, cannot connect to Infinispan. But that's fine, because we're going to ignore that one. But it's more important, if we go now back to the logs, we should be seeing the entries being read. So if we go to the logs now, we see 1 second at the time we gain one entry from the file being read. Okay, so we've managed to read entries from the file. Next, we need to take those entries and we need to push them into Infinispan. To do that, we're first going to create an Infinispan instance of 3 pods, as we said. So what we can do is we can call add project up here, and call select from project. We zoom out again. We can click Infinispan ephemeral. That's the template that we've loaded. And what we're saying here is that we're gonna create an Infinispan instance which only stores data in memory, so no persistence attached to it. We select it, then we click next, next, and then here what we see is the configuration. We've got different attributes that we can tweak. The application, we're gonna call it slightly different. We're gonna call it data grid, which is what we said in the slides before. And then we're gonna define a management user called developer. That's gonna be a management user that then is gonna be used by a visualization tool that is going to interact with our application. Next, we take here we define the image that we're using, and we define the number of instances as being 3. So we want 3 pods created. These pods are going to be created in a cluster where they're going to be finding each other. So if we go to the overview, we see now that our data grid is being loaded. Okay, we see that it's being loaded now. So what we want to do next is we want to go from reading from the file and storing data and presenting data to the standard output to actually storing it on Infinispan. For that, what we're going to do is we're gonna using a little facade we've created here that exposes the Infinispan remote client with an RxJava API. So that means that we can create an Infinispan kind of map, key value map like API, and then we're going to be able to go create index. We see the difference in a little bit, and we're going to be able to call different operations. Put to store the data, and we're going to be able to call size to get the size of our entries, and then we use the other operations later on as well. So if I go to the station boards vertical, the first thing that we need to do is we need to say, how are we going to connect to Infinispan? Well, first we need to give it the host and the port where we're going to be connecting to. For that, we can create new configuration builder. That's the class that is going to be our configuration. And then from the configuration, we can say add server. We give the server the host. The host here, DataGrid host, refers to the DataGrid service, which we'll see in a little bit. And the port is going to be the DataGrid port. Okay. Now, what's this DataGrid dashboard? So if we go to the Chrome instance, we look at our DataGrid, which has completely loaded. We have a service name called DataGrid photo. This is our binary endpoint that's been exposed by the DataGrid. So this is our entry point, our host that we need to be looking at from the application. So then with this configuration, what do we need to do? Is we need to go to that interface in Infinispan Rx map. We can say we're going to create an index map. That is because we're going to be storing the data, but we also are going to be wanting to index it. We're going to be indexing in order to then extract some meaningful data out of it. So I call create index, and I give it a map name, which is the name, like the namespace within Infinispan we want to be using, which is going to be a station boards, and then we pass in the map name. We want the classes to index. Here I've already got in cache in something called toIndex. So if we go to toIndex, we see that 3 classes appear. The most important one is called stop. Stop basically is our way of representing the data from the streams, the binary files, each binary entry into here. Now, if we go to our presentation, I can show you what each of the lines are going to be looking at. For the stops, here is what each individual line of the file looks like. So we've got in a JSON format of information about a particular entry in a station bus. So it tells us that there is a train, for example, here named Interregion 178 that is going to Basel, and this information comes from the train station of Rheinfelden. And then one thing that is going to be important for us is going to tell us whether the train is delayed or not. So it tells us in number of minutes. So if I go to my Java application, what we're doing here is taking this JSON that you see in the screen, we're converting it into a POJO that then we are annotating it with some annotations that allows us to index the data. So underneath what we're using is ProtoString that creates Google protocol buffers, binaries that then they can be deconstructed by the Infinispan servers and they can index the data. So here, the most important field we're going to be interested in is the delay minutes. This is going to be an integer telling us whether there has been a delay. So if there is a delay, this value is going to be bigger than 0. If not, it's going to be below 0. So to go back, we wanted to create an index map for this map, indexing these fields with the configuration that you see that we defined above, and we're going to have a little help of vert.x to do things internally. So we've got the map. What we want to do next, very similar to what we did, say, okay, if we get the map, we want to assign it locally. So we take the map that we get, and then we call station boss map, we assign it to that map. Okay, we said that the map needs to be assigned, but we still need to kind of force the types of the map and the keys and values, which is a string to a stop. Next, what we want to be doing is when we call to inject, what we want to be doing is we want to be start by clearing the map. This is we do so that we can call multiple times inject and for them to be idempotent. So we call it clear, we call clear. and then we call, and then we're gonna start a little progress kind of log that shows us how many entries have been stored so far. So we can call track progress here. This sets a periodic invocation that every 5,000 milliseconds we want to show the size of the map in the backend. So here will tell us how much entries have been stored so far. Now, once the progress has been set, we start reading from a file, we take each line, we convert it into a key value pair, and now we need to actually store it into Infinispan. So we change this line to say station boards. We're going to be putting the key that we get and the value that we get. And that's it. That's all we have to do. So if we go now to our application, to our actually, before I go, one more thing I need to change. We go to the application utils. We said that we were throttling each entry that we store into Infinispan. That we read from the file. We said we are throttling every 5 milliseconds or every second. So what we want to do is we want to switch it so that it's actually faster. So it's every 5 milliseconds read one entry. The way we do this again is so that we get a more pleasant feeling. Not things are not happening too fast, but not too slow, so that we can see things evolving at a good rate for us users to know to understand what's going on. So with this in place, what we need to do next is we need to go and deploy our application with these new changes. So we go to the command line. We're already in the application folder. So to deploy, what we can do is we can say Maven Compile, and then we're going to go OC start build application from directory, the current directory, and then follow the links. So this is going to deploy our application, updated application. So if we go to the Google Chrome, we can see our application. There's a new build happening, and within a few seconds we should be seeing how the current pod is being shut down, and then a new pod is started, and it's scaling to 1, and it's de-scaling the other one, and we got version 2 running now. The next thing that we want to do is, apart from the log, we want to show you a little bit more visual way of showing the data grid being filled up. So what we're going to go is we change to the previous directory, and we go to a folder called Visual, and then this is here what we have is a visualizer of the data grid. So what I'm going to call is we have a deploy script that is going to do a binary upload of this application that is going to allow us to visualize this. So I'm just going to call deploy to the stage. What this does is essentially starts, we do OC start build again into a data grid visualizer, which you'll be seeing in a few minutes, and we should be appearing in our screen. So we see that it's pulling an image. This image is from Wildfly. This is one that is needed for our application because this is a visualizer. It's a WAR application that currently runs on top of Wildfly, which is why we are downloading currently the Wildfly image. So once that is in place, we're going to be able to load it up. We're going to be able to connect to Infinispan, and we're going to be able to see our data being populated. So while that is happening, we can go to our application. Actually, it's moving along nicely. So apart from that, I can explain a little bit more what we're going to do in the next few steps. So once we've stored the station board data, what we're going to do is we're going to try to extract meaningful data out of it. And for that, we're going to be using continuous query functionality. Continuous query functionality is functionality that allows us to take some create a query against the data that is in our data grid, and we're going to be able to, whenever data that is stored into Infinispan that matches our query, we're going to be getting both. This is very useful functionality for creating a dashboard. So well, that is happening. Okay, our Wildfly is being downloaded still, so let's hold on a few minutes for it. So what we're going to do is we're going to get a continuous query, and we're going to start calling in. So the way we can call a continuous query with our RxJava facade that we define, we can call the map call continuous query, and then the query is going to be the one that you see above here. So we're saying from the stop class, we want to get all the stops where the delay minutes is bigger than 0. So we just take that query, we pass it into a continuous query. So what we're going to get is we're going to get a flowable. Flowable essentially means that we are going to get, for each entry that matches our query, we're going to get an invocation with the keys and the values. Then what we are going to do with each key value pair is we're going to push it over the vert.x event bus, which underneath is going to be using the SockJS bridge to push it into a dashboard that we're going to have. So we're going to have all the delay trained information pushed into a dashboard. The way you do that is we're going to be calling vert.x.eventBus. We're going to publish it to the address that we defined above, which is called delay trains. Then we're going to take that POU, the value part, and then we're going to convert it into some JSON that is understood by the front end. So we can do pair.getValue plus our stop. So if we go to our command line, we see that Wildfly is still being downloaded, so it's taking a bit of time. So in the meantime, I'm going to explain to you a little bit how the dashboard works. The dashboard is a JavaFX application. So if you go to the dashboard, you can see it here. Dashboard is a JavaFX application that is going to show us a little table. And then the most important part is happening in the Websocket Task. This tag is essentially going to create a WebSocket client to the following address, which is with the host and a port that we're going to define. And that's going to go to delay trains WebSocket. And then what we're going to do is for each entry that we get, is we're going to push it into our dashboard. So the WebSocket part is to bridge between the event bus and the WebSocket endpoint. We've got a SockJS bridge. This has been initialized when we created our main. So if we go to our main class, on the start we've created a SockJS handler for it. We also said that if we connect from the dashboard, we re-inject the data. So that's what that makes it for easy to experience. So we've gone to a command line. Finally, our data grid visualizer has been completed. We've downloaded the Wildfly. We built it. So now, if we go to the our OpenShift, we see our data grid visualizer is stored there. So what we are going to do is we're gonna first load up this visualizer. So what we do is we right-click the address. We open our another tab, and then we go to the address /Infinispan visualizer. And here you should see in a minute or two. Let me refresh that. Okay, there we go. We see our three balls, multi-color balls. These represent the three Infinispan nodes that we see in the backend. You see for each of the address, we've got the IP address, the internal IP address, along with the port, the 11222, that's the binary port that we talked about earlier. And we see that each of the entries have 0 entries. If we go to up here, you can see we can select the caches. So we're gonna select the station board cache because that's the one that we're gonna be interested in. So what we need to do now is we need to go to our command line, and we need to call inject again. So once we call inject, the data will start being populated into Infinispan if we haven't made any mistakes. So we call inject, we said now it tells us injector started, so that's fine. So if we go now to our visualizer, we can reload it. We should see the entries being populated. Something. Okay, there we are. The visualizer is a little demo tool, so sometimes it doesn't work as smoothly, but it's just one little demo tool that we have. So we see that we have entries are appearing in our data grid nodes. We see that each of the nodes has got the number is increasing. The numbers are not exactly the same. That is because we keep in 2 copies for each piece of the entry, and these are we use consistent hat distribution to share it with the other nodes, and then the counts are slightly different but very close. We can also, if we go to the console, the OpenShift console, if we go to the application, as I said before, if we look at the logs, we should be able to see how these positions are being stored. So we see these logs messages here, for example, that is saying the store 30,000. We also see some other log messages. These are going to be useful for us for later on. But we also see, for example, that train positions are being loaded. This is also going to be useful later on. Now, we finished the implementation of our continuous query, which is going to allow us to now extract the information. So far we've seen, we've demoed how we can store the data. What we're going to do next is we're going to deploy the application with these new changes of the continuous query. So to do that, we go back to our application, and we call Maven Compile again, and then we start deploying the new version of the application. Okay, so we see that the build has started, which puts the changes. And now if we go to our OpenShift console, go to the overview, we see our running deployment is happening. See the scaling from 0 to 1. And now we've got our version 3 running once again. So if we go to number 3, we go to the logs, we restart. Now, what we are going to do next is we're going to start our dashboard. So our dashboard here, I'll take a little dashboard, and we're going to be calling, we're going to run it. So what the run is going to do is going to start our JavaFX application. It's going to connect via WebSocket to the server. It's going to tell it to re-inject the data, and then if everything is working fine, we should be seeing entries appearing of delayed trains. So what we can do, we run the dashboard, it's compiling. So we see our Java application starting up. We see a connected message here, and if things are working fine, within a few seconds we should be seeing some entries appearing as well. Voila! We're seeing that data is being injected, but in the background we gain information about those trains that are delayed. We see that there are trains, the Rio Express 5343, going to Basel is delayed, etc. So it's delayed by 3 minutes. So you can see here, we can, if someone asks you, are trains delayed in Switzerland? They are delayed, as you can see here. Doesn't happen very often, but they are indeed delayed. So we've seen so far how we can take the data from the station boards, put it into Infinispan, use continuous queries to get relevant information about it. Now, what we want to do is combine this information with the one about train positions. So what we want to do is we want to track each of those trains that are delayed, and we want to find the positions, and we want to show up in a little map. So to do that, what I'm going to do next, I'm going to get ahead of me. I'm going to start a web application that we can be using. So I'm going to go to the web viewer, and then we're going to start it up. This is going to be an application that is going to be running locally with all that is going to show us that Google Maps with the positions. This application is a Node.js application. Here, what I'm doing in this start script, I'm loading the Node version manager. This is a very useful tool for managing multiple Node.js installations. If you already have Node.js deployed in your own machine, you don't need to use NVM. You can use your NPM directly. Here, we use Node.js 4.2. All higher versions should work fine, but we know that one works, so that's the one we're sticking to. So we're going to start it up, because starting up is going to do an npm install, so it's going to download a bunch of npms for us, so that's why I want to do it ahead of time. So in the meantime, we're going to complete the code to be able to do this. So we're going to start by, we're going to stop our dashboard for now. Okay. And then what we are going to do now is we're going to complete the rest of the code. So the next part of the code, what we need to do is we need to kind of join together the two informations. The information about the station board together with the one about train positions. For that, what we're going to do is we are going to go to this class called train positions vertical, and then what we are going to do is we're going to say, okay, from the dashboard, we knew those trains are delayed. That's the train name. But if we go, our train position map is keyed on train ID. So I can't just call map.get with a train name, because the train name doesn't match the train ID. So what we're doing here is we're saying, okay, go to the train position map, find me the train ID with this train name. Okay. So to do that, we're doing queries, normal queries, to find the train positions. So to do that, here we've defined an equal query, which is an Infinispan query, and we're saying we want to find out the train ID from the train positions where the train name equals this one. So obviously here this is a JPL style query. So what we want to do is we want to add a parameter to this query. So we can say with the name, or the name parameter, that is going to be train name. Okay, so we've got our parameter. Oops, yeah, that's what we are going to do here. Yeah. And then what we want to do now is create the query. So what we do is we get here we got a train positions map. We call .query with the query string, and we pass the query parameters. Now, what happens is this query, because I'm not doing a from train position only. We're saying I don't need right now the entire train position. So I'm saying I want to select the train ID field. So you could potentially select multiple fields. So you could just say train ID, train position, etc. But here I'm just selecting one. So obviously what you get out of the query is an object array. Now, out of the object array, because we only have one field here, we only select the first one, and we cast it to a string. Then what we do here, we actually locally cache it in a map where we keep train name to train IDs. Now, the way the map is going to be, the Google Maps is going to be updated. It's going to be by publishing, again using the event bus, and we're going to be publishing the positions of those delayed trains periodically. So here, what we are going to be doing is we're going to say, when we start this vertical, when we start a train positions publisher, that publishes position every 3 seconds. So then what we're going to take our positions, push them into the event bus, into the delayed position address, and these are going to be fed again using the sock.js bridge. They're going to go to the front end. Now, if we look at the sock.js code, there is a very important thing that we need to understand. We don't want anything that we push into the event bus to be exposed externally. That would be a huge security risk. So what we can pass an address to say we allow this particular address to be sent to the outside world. And this is what we're doing. Here we use the delay trains, we use that from the dashboard, and in the one below, we're talking to the delayed positions. Okay? So now we should have our code completed. Okay, so what we need to do, we need to go to our command line. We see there are application now. It's running our web viewer. So if we go to the browser, I can call localhost 3000. That's gonna show us a map. Right now it's gonna be empty because we haven't completed the code. So we need to go back to our command line. I'm gonna start a new terminal, make it a bit bigger, go to the screencast directory, and then we're gonna go to the streaming data Kubernetes. Now what we need to do, we need to go to the application, and we're gonna do that Maven Compile that we did. Maven Compile and start the build from here. I might need to bring my OC into here because I've started a new terminal, I don't have it, but I can call Maven Compile and start the build. So that now is gonna take those changes, it's gonna update them, it's gonna push them into the backend. Okay, so if we still remain here, see the application has been deployed. So if we go to our OpenShift cluster, we can now go to the overview, and we see that there is a new version of the application being deployed. The application is being scaled down and scaled up. Brilliant. So we go to the application, we can see the logs. We get a little error that we don't need to worry about it at the moment. So what we need to do next is we need to start our dashboard again. So I go back to the project and I'm gonna start the dashboard. And if everything is working correctly, the dashboard should restart the injection of data. And as a result of starting the injection of data, hold on a second because there's also some indexing happening locally. So the application is going to start. Then we will find out we start the injection again. So again, once again, we'll start seeing in a few seconds informations about delayed trains. If everything is working fine. Let's see with our delayed ports. Start the indexing here. Okay, sorry, it took a bit longer probably because it was indexing the data. So we see all the trains are appearing here. So if we go back to the train positions, we should start to see them being pushed. We don't see them being pushed. That has happened. So we can, this is a bit of live coding, the application. They should be pushed. So let me restart the application. These are not appearing. Why are not appearing? Could be just let's see. So we can load the script console. Okay, no, we should be seeing them. For some reason, not being loaded. We restart the application. That's npm. Yes, let me bring my when I use for the 2 should be saying nothing there. Oh, we've seen them. Haha. It's just I wasn't looking at them. They were not appearing here. But I think it's just that I didn't zoom in. Haha. They were appearing. So we can start them again. Start the injection again because I think the having the indexing happening at the same time has messed up a little bit my setup. So let's go back. Let's repeat this again. It's just a few things running on the local host. So if we got our web application loaded. Our web application is loaded here as well. So what we can do is call our dashboard again. That should start re-injecting the data. and we start seeing those delayed trains. So if we go to, there we are appearing now. We see those Regio Express 5343 appearing there. That's going to Basel. We see them slowly moving across. We see them is going to Basel. So we see that the Regio Express is delayed. What other delayed trains do we have? I know there's a particular area between Geneva and Lausanne that is currently that is a very busy area. So and I know for sure that there's going to be some delayed trains. And indeed there are. It's just one of the busiest areas trains-wise, and we see quite a few delayed trains actually. So we see one going to Coppet, the Regio 11059, the ICN 531 going to Zurich is also delayed. Oops, yeah, that's moving quite fast. That's a very fast train. So that's all I wanted to show you today. We've shown you how you can build a couple of applications, one a web application, the other one a dashboard with delayed trains and the positions using data that comes from two standard outputs, two publicly available entries, HTTP endpoints. One comes from transport.opendata.ch. That's the data about the train stations comes from there. The other one about the train positions that comes from SBB, which is the Swiss railway station, the railway company directly. So then we've seen how we can match these two streams of data together to do some fun stuff. And with that, that's all I had to say today. Hope you enjoyed the recording. And yeah, see you next time.